In this lesson, we're going to learn more about equivalent fractions. These are fractions that have the same value. Here I'm showing you three different models. This is the first model. It's the whole. One out of those two parts, or 1/2. And we're also showing you another model, also a whole there. And then how many parts do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So we have an 8 there. And we have a 4 in the numerator because we have 1, 2, 3, and 4. Now I think you'll agree with me that 1/2 does equal 4/8. We call 1/2 and 4/8 equivalent fractions. In fact, if you look at this last model over here, this is divided into tenths. 5 out of those 10 parts are shaded, so 5/10, 4/8, 1/2 are all equivalent fractions. We're showing you some more equivalent fractions for 1/2. If you look at 1 out of those 2 parts shaded right there, 2 out of those 4 parts are shaded, 4 out of those 8 parts, and all of those are equivalent. So we have 1/2 does equal 2/4, does equal 4/8, does equal 8/16. Now if we had gone through there, and if we were talking about 30 seconds, do you know what that numerator would be? How many 30 seconds is equal to 1/2? Were you thinking 16? Did you say 16? Let's look at some more fractions. If we had 1/3, and I drew a model for 1/3, I think that you'd agree with me that 1/3 would look like that right there. Now if we divided each of these thirds into halves, that in half, that in half, that in half, now what are we talking about? Now what are we talking about? Are we talking about thirds still? Nope. We're talking about 6. 1, 2, 3, 4, 5, 6. We're talking about 6. And how many of those 6 are shaded? Right, 2. Now I could go in there and divide each of those in half again, except I think it'd get very messy and be hard to see. But if you see here, this 3 goes to 6. And then if we multiply it by 2 again, we divided each of these in half again, each of those was in half again, we would end up with 12ths. If we did that in the denominator, what we'll see is we'll have to do the same thing in the numerator to get 4/12. So all of those there are equivalent fractions. 1/3 and 2/6 are equivalent fractions because they have the same value. They're worth the same thing. And they are also equal to 4/12. If we continued this, we could also have 20/4. How many 20/4 would that be? Did you say 8? Good job. Mathematicians, they're saying, oh, I don't know if we should really draw models and models and models and models. Now, oftentimes they're lazy. Where it is they're talking about things like this here. And then they would say, oh, I want an equivalent fraction for 3/5, but I want to write it as 20ths. And then so what they'll say, and what we'll do, is we'll do that same thing that we were doing on the previous screen there. How did we get from 5 to 20? What would we have to multiply to get from 5 to 20? We multiplied by 4. Now, what I was saying on the previous screen is that if we do one thing in the denominator, we must do the same thing in the numerator. 3 times 4 is 12. Now in our picture, if we were to think about this, what we were doing is we were taking each of those fifths, and then we were dividing it 4 more times so that we would get 20ths. We would end up getting 20ths. That's what we were doing. And it's so messy that this is going to be that much more accurate for you. But you do have to understand the reason why we can do it. You try. Next screen. Copy them down. 2/3 is equal to how many ninths? And I'll help you out just a little bit. How did we get from 3 to 9? What did we multiply by? And 5/8 is equal to how many sixteenths? Hit pause, and I'll come back with the answers. Here's your answer here. Times 3. You better do the same thing in the numerator. So 2/3 is equal to 6/9. Now I think that you'll agree with me, once we start thinking, we just be all, well, it says to write an equivalent fraction. Didn't it mean that we could write any equivalent fraction? Well, kind of. But what I did, so that we would be on the same page, is that I made those denominators for you so that we had to do one thing there. If we look at that second one, it's 8 times 2 gets to 16. So if we multiply by 2 in the numerator as well, we get 10/16. So 5/8 and 10/16 are equivalent fractions. All right, here's a little quiz, here's a little test. I want you to see if you can go ahead and find that equivalent fractions. Which two are equivalent? 1/2 and which one? Look around, think, think, think. 1/2 and what? Ideally you said 4/8. Let's take a look at another one. Let's look at 2/3. Look around. See which of those is an equivalent fraction. We multiplied the same thing in the numerator and denominator. What'd you come up with? 4/6. So if you multiplied by 2 there, and we multiplied by 2 there, we get that other one there. Look for some more equivalent fractions. Did you come up with 3/5 and 6/10? Remember that our inverse operation of multiplication is division, so we could just divide by 2, and if we divided by 2 in the numerator, guess what we do in the denominator? We also divide by 2. So 6 divided by 2 is 3, 10 divided by 2 is 5. Now out of those remaining that are on the screen, go ahead and point at the 2 that are equivalent. Point at the 2 that are equivalent. Right, 5/8 is equal to 15/24. Now I'm going to throw out a term for you. This 10/15 is not in simplest form, and to make it into simplest form, we're going to do the same thing in the numerator and denominator to write an equivalent fraction for it. 10 divided by 5 is 2, 15 divided by 5 is 3, and 2/3 is what's called into simplest form. It's much easier for me to draw 2/3 than it is to draw 10/15. Now for this video, you can just remember that 10/15, 2/3, those are equivalent fractions. Just like we can go ahead and go in that direction, 10 divided by 5 equaling 2. Remember, it was 2 times 5 equaling 10, and 3 times 5 equaling 15. And so those are equivalent fractions as well. There's your lesson on equivalent fractions.